So our next one is going to be a little bit tricky right away, just in terms of identifying what the inside function is. Now, in the Rogowski, on the first, up to number 22, they tell you what to use for U substitution, so that makes it a little easier. On this one, you might guess that secant is the inside function because it's inside the squared function. But the problem with that is that the derivative of secant is secant tangent, and I don't have secant tangent, I just have tangent. So what I can do instead, and by the way, there's more than one way to do this, is use tangent as the u. Because if I do that, then the derivative of tangent is secant squared, so then I already have the du right there. So that's what I'll do. I'll use u equals tangent x, and du equals secant squared x dx. So watch how that's being written. U equals x, du equals dx. All right, then make your substitution. So this is the integral of, well, so du is taking up that whole tangent x. So that whole tangent x is just going to be u. And then, I've left the dx off my integral, which was faux pas there. So my du is really secant squared x dx, right? Secant squared dx is du. So the secant squared and the dx, they're coming together to just be du. And now I just have the integral of u du. Well, what do I do with that? Well, that's power rule. The antiderivative of u is u squared over 2, just like the antiderivative of x is x squared over 2. I'm doing the antiderivative at this point. I put a plus c, right? The integral sign, the du, they go away when I do the antiderivative. So now I don't have those, but the plus c shows up. All right, so stepwise, I have up here all x's. I do my u substitution. Now I have all u's. I have integral dx, then I have integral du. Then when I do the antiderivative, no more integral sign, no more du, but the plus c shows up. All right, so that's sort of what happens at each step. All right, then the last thing is I need to sub back my value of u. I said u is tangent x, so this is going to be tangent of, well, let me write it like this, 1/2 tangent of x squared plus c, or if you like, you can write that as 1/2 tan squared x plus c. So that's number 18. All right, next up, I'm going to do number 28. Number 28, it says the integral of dx over x minus 9 to the 5th power. All right, so do I want to do this out to the 5th power? No, I don't. I want to make a substitution. What's my inside function? X minus 9. U equals x minus 9. Du equals 1 dx, so it's just dx. All right, now what am I going to do with this like du over? So when I go ahead and do the substitution, my dx is du, so dx is du. All right, I'll make that vinculum black there. And then my x minus 9 becomes just u, and that's to the 5th power. All right, so what do we do with du over u? Well, this is really sort of a shorthand, a way of writing what they really could have written, at the very beginning here. They could have said that this is just sort of a shorthand way, or a nice way to write 1 over x minus 9 to the 5th power dx. So sometimes we just put the dx on the top. So we treat that dx like a variable a lot, but remember, it isn't really one. This is really 1 over u fifth du. I'm keeping the integral sign because I haven't done an antiderivative yet, right? All I'm doing is substituting and doing algebra. Now, I'm still not going to do calculus yet. If I want to do 1 over u to the 5th, I have to write that as a negative exponent, u to the negative 5th du. Now I'm ready to do the calculus, so I'm going to drop the integral sign when I do the calculus. 1 more than negative 5 is negative 4, so it's u to the negative 4 over negative 4 plus c. Yeah, you could leave it like that, but we have to at the very least sub the x back in. So let's write it as negative 1 over 4 x minus 9 to the 4th power. Right, so I just put that negative out front. Kept the 4 in the denominator, and my negative exponent, I put it into the denominator. All right, that's number 28. What up? Next, I'm going to do number 68, jumping ahead. All right, because number 68 looks pretty weird, and they didn't even tell you. So after number 27, they stopped telling you what to use for du, and you have to kind of figure it out. So number 68 is a weird one, because it says integral of dx over x ln of x squared. I didn't write that right. Integral of dx over x ln of x squared. All right, so various things we're going to keep in mind. We're going to keep in mind that this really means the integral of 1 over x ln x squared dx. That's what this means. But you're generally not going to write this. You're going to leave it like that. So here's the other thing you should be thinking. When you see like a log lurking around, you see an x in the denominator, you need to be thinking about that the derivative of ln x is 1 over x, and that's going to cause an x to show up in the denominator. So in fact, that's what our u is going to be here. Our u is going to be the ln x. All right, so then I can say that u equals ln x. So du equals 1 over x dx. And see, I've got that 1 over x dx right here. In fact, you could rewrite this like this. The integral of 1 over x times 1 over ln x squared dx. And then this right here is your du. And then what else have I got? I've got 1 over, my ln x is my u. So I have 1 over u squared du. Now, how am I going to do that integral? I'm going to rewrite it as a negative exponent. So far I have not done any calculus. It's all algebra and rewriting the integrand, first breaking it down in different ways, then making a u substitution, but I have not done an antiderivative yet. Therefore, the integral and d something stays all the way down. Whenever I have x's, it's dx. As soon as I change to u's, it's du's. X dx, u du, u du. The x and the u shall not mix within the integrals. All right, so now we do our antiderivative by raising the exponent 1, divide by the new exponent, put a plus c because I did the antiderivative. And now, let's see, I can just pull the negative out, and I have u to the negative 1, so that's ln x to the negative 1. And, you know, I could leave it like this if you wanted, but wouldn't it be nice to make it negative 1 over ln x plus c? And that's what that antiderivative is, and that's number 68.